Okay, so now let's just summarize some properties of square roots. So, summary of square root properties. First of all, just very basically, the definition, right? So the definition of a square root, we denote using this sign, which is the radical sign. So we have some number squared. When we take the square root of it, that a squared is really a times a. We simply get, without the square root sign, we get a back, right? So, for example, if I have the square root of 25, 25 is a perfect square, right? 25 is the same as 5 times 5. So if I take the square root of that, simply 5. And as I said before, it's a good thing to know your perfect squares. Up to 15. It'll help you with factoring and being able to pull things out from under the radical quickly. Okay, so that's the basic definition. Now, when we talk about addition and subtraction of square roots, the big thing to know is that the square root of a plus the square root of b does not equal the square root of a plus b. Okay? It does not equal that. So I don't ever want to see that. Right? So as an example, square root of 2 plus the square root of 3 does not equal the square root of 5. Okay? However, if I have the same radical parts for something, so let's say I had 2 times the square root of a plus 3 times the square root of a, if you notice my radical parts are the same, right? So that's like saying I have the square, can factor out a square root of a, and I'm left with 2 plus 3, so that gives me 5 square root of a's. Just like we worked with like terms, this is like we have the same radical parts, right? So that part works. You can add things up as long as you have the same radical part. Multiplication. Now for multiplication and division, you can bring things together under the radical. So if I have the square root of a times the square root of b, that actually equals the square root of a times b under the radical, right? So as an example, if I have the square root of 2 times the square root of 7, that actually equals the square root of 2 times 7, which equals the square root of 14. Remember, this does not work with addition or subtraction, but it works with multiplication. And it actually works with division as well. The other property we want to remember is when we talk about distributing. So if we have the square root of a times the quantity square root of b plus the square root of c, that's going to equal, so we take these and we multiply them out. That equals the square root of a times the square root of b plus the square root of a times the square root of c. And as we saw before, this is simply square root of ab plus the square root of ac. And then the last property is when we talk about division. So when we talk about division, since division is, the properties are very similar to multiplication, since division is simply the multiplication of the reciprocal, right? We know that if we have the square root of a divided by the square root of b, we can put them under the same square root sign and have square root of a, the square root of a over b, right? And by the same token, if we had them both underneath the radical together, we can split them up as well. So these two work like that. So now if I have an example, I have the square root of 18 divided by the square root of 2. In this case, instead of trying to rationalize the denominator, I'm just simply going to say, well, this is the same as the square root of 18 over 2, right? And that's really the square root of 9, and then in our case here, it's a perfect square, so that's just 3. And then if we have, say, the square root of 25 over the square root of 25 over 49, we can split these up, 25 square root of 49, and that's the same as 5 over 7. And remember, the last thing we talked about was rationalizing the denominator. Meaning we can't have a square root sign in the denominator of a fraction. Right, so if I had, so basically if I had 3 over the square root of 2a, we can't have the square root of 2a in the denominator and consider it simplified. So all we have to do is we can take our original, and we want to get rid of the square root sign in the denominator. So we're going to multiply this by itself in the numerator and in the denominator now. Because what's the square root of 2a times the square root of 2a? 2a. No square root. 3 times the square root of 2a, and that's simplified because you can't have a square root in the denominator. And we did. We got it out, but in some ways we brought it up. But this is rationalized. Okay, and that's pretty much square root properties in a summary. So now you can practice working on your modules.